Balancing equations means that you have to have the same number of each element on both sides. So in this case here, I'm going to start with lead and look at those. Since there's only one lead on both sides, I don't need to do anything. And I'm going to skip over to potassium, and I'll explain the reason why I'm skipping to potassium for the next element that I'm going to balance is because the others are polyatomic ions, and I'm going to do those next. The K, there's two Ks on the reactant side and only one on the product side. In order to get them to balance, I'm going to write a 2 in front of the KNO3. That'll make it so there's 2 Ks on both sides of the equation. Next, I'm going to look at the polyatomic ion NO3. Now the key to this is to treat the polyatomic ion as one unit. So think of this as a NO3 over here. These are together. So on this side there's 2 NO3s, but there's only one NO3 on this side. So in order, except for I have a 2 in front, which makes it so I have 2 of everything else. So the NO3s balance on both sides. The last thing that I'm going to look at is the CrO4, and that is a polyatomic ion. It's the same on both sides, and I have one CrO4 on both sides, so it's balanced. So my coefficients are 1, 1, 1, 2. The next balancing equation problem, I pick sodium, and I have 1 on both sides, so they're balanced. Next, I'm going to look at hydrogen. I've got 2 hydrogens on both sides, so they're balanced. And I look at oxygen. I've got 1 oxygen on both sides. So this is a nice, easy one. It's already balanced with the coefficients of 1, 1. Oh, no, it's not that easy. Okay, the second one, sodium, is the first one that I'm going to look at. It balances with 1 and 1. Then I look at oxygen next. The reason why I'm skipping hydrogen is because hydrogen is found in 3 of them. So I'm looking at oxygen, and I see that it's already balanced, so I don't need to worry about it. Then I go back to my hydrogen. I've got 2 hydrogens on the reactant side, and then I have 2 plus 1 on the product side. Well, since my hydrogens come in only 2s on the reactant side, that's an even number. I have to have an even number on the product side. The only way I can do that is by having an even number in front of the NaOH. So I'm going to start out by putting a 2 there. That makes it so I have 2, 4 total hydrogens on the product side. And I have 2 hydrogens on the reactant side, and I want to have 4. So I put a 2 in front, making a total of 4 hydrogens. So my hydrogens are balanced, but I look at check my oxygens. I've got 2 oxygens because I've got 1 here, but I have a coefficient of 2 and 2 oxygens. So my coefficients are 1, 2, 1, 2. My next one, I have 1 barium, 1 barium. They're balanced. Then I look at my chlorines, and I see that I have 2 chlorines over here and only 1 over here. So to make them balance, I'm going to put a coefficient of 2 in front of the HCl. That makes it so that I have 2 H's on the product side, 2 H's on the reactant side. So my next thing I look at is my SO4. This is a polyatomic ion, so I treat it as a unit. There's an SO4 on both sides. So my answer is 1, 1, 1, 2. For 46, this time they write it out as a sentence, and we have to figure out what formula this is. So the first thing I do is I look through it and find the chemicals. And calcium is a chemical. Calcium hydroxide is another chemical, and hydrogen is another. So it says the equation shows calcium metal. Calcium, when I look it up on the periodic table, has a symbol of Ca, and it's a metal, so it's going to be a solid. And water is the other chemical here. So calcium metal and water. Water is a liquid at room temperature, so an L. And then to form is the arrow. An aqueous solution of calcium hydroxide. Calcium is +2, hydroxide is -1, so you need 2 hydroxides. And hydrogen gas. Hydrogen is one of the diatomic elements, so it's H2. Now I can go about trying to balance this. I've got 1 calcium on the reactant side, 1 on the product side, so they're balanced. Then I look at my hydrogens. I've got 2 on the reactant side, and I've got 4 total on the product side. So to get them to balance, I put a coefficient of 2 over here, and that makes it so I have 2 oxygens on the reactant side and 2 on the product side. So my coefficients are 1, 2, 1, 1. On the next one, identifying the compounds, iron 3 oxide, carbon monoxide, to form, and the to form is the arrow, and then my products are going to be iron 2 oxide and carbon dioxide. So naming these or writing the formulas, iron has a +3 charge and oxygen has a -2, so we use the crossover method and get Fe2O3 reacts with carbon, and mono means 1, so 1 oxygen, so it reacts with carbon monoxide to produce or to form. And then iron with the Roman numeral 2 means it has a +2 charge. Oxygen has a -2 charge. So they balance out as FeO, and, which is our plus sign, carbon, and then the di means 2, so carbon dioxide, 2 oxygens, CO2. Balancing this out, starting out with the irons, there's 2 irons on the reactant side, only 1 iron on the product side. So coefficient of 2 over here will balance my irons. Then I look at my carbons next. The reason why I skipped my oxygens is because oxygens found in every one. Carbons balance out. So then I'm going to look at my oxygens. I find that I have 3 plus 1, that's 4 over on this side. Over here I have 2 plus, and then there's 2 over here, so I have 4 on the product side. So my coefficients, everything's balanced, 1, 1, 2, 1 for my coefficients. The last one for balancing the equation, again finding the elements in here. Potassium reacts with water to form, and then potassium hydroxide, and hydrogen gas. So potassium metal, potassium is an element, so I look that up. It's a solid at room temperature, and with water, it's reacting with water, H2O, and then it's forming potassium hydroxide. Potassium is K. Hydroxide is actually a polyatomic ion, even though it ends in "ide." And when you look it up, it's OH with a negative charge. So since those charges balance out, it's KOH. And the potassium hydroxide and The other thing that's formed is hydrogen gas. Since hydrogen is diatomic, it's written as H2. Balancing this equation, there's 1 potassium on the reactant side, 1 on the product side, so they're balanced. Looking at the oxygens, there's 1 on the reactant, 1 on the product side. So now the hydrogens are the trick, because there's 2 on the reactant side and there's 3 on the product side. Since on the reactant side it only comes in even numbers, I have to make sure that my product side's even. I'm going to do that by putting a 2 in front of the KOH. That's going to make it so I have an even number of hydrogens on that side. Now I have 2 hydrogens here plus 2 more over here. That's a total of 4 hydrogens. And so over on the reactant side, to get 4 hydrogens, I put a 2 in front. This balances out my oxygens. I've changed my oxygens, but they've stayed balanced. So my coefficients are 1, 2, 2, 1.